Now let's think about dependent events. So that means the outcome of one event does affect the outcome of another. So a good example of this is picking cards from a deck and not replacing them before picking the next. Okay, so let's look at, just for an example, chances of drawing aces. I'm just going to look at drawing the first two cards from a deck. So I'm going to do a tree here. So the first card we draw, there are 52 cards available. And 4 out of the 52 are aces, and 48 out of 52 are not aces. Tilde means not. But then the second card we draw, there are 51 cards available. And so in this case, we've got 3 aces left out of 51. So here we'd have an ace. So this is the chance of drawing a second ace. And we've got 48 not aces out of 51. So this would give us ace and a not ace. And in this case, similar idea, so we've already drawn an ace, so we've still got 4 aces left out of the 51 cards. So that means we'd get a not ace and then an ace. And here we've got 47 not aces left out of 51. So that'd be not ace, not ace. Then we can, this is an and, so this is a probability of drawing this and this. So we just add, so we have to multiply the probabilities. So that would be 4 out of 52 times 3 out of 51, which is 12 out of 2652, or 1 out of 221, or 0.00452. So that's not very likely, isn't it? That's less than 0.5% of the time you're going to draw the first two cards as aces. Okay, and just the same going down the line, so 4 out of 52 times 48 out of 51, which is 192 out of 2652, or 16 out of 221, or as a proportion 0.0723. This is exactly the same, only the other way round. So that's 48 out of 52 times 4 out of 51, 192 out of 2652, 16 out of 221, 0.0723. And then finally, not ace and not ace, that's 48 out of 52 times 47 out of 51, which gives us 2256 out of 2652, or 118 out of 221, or 0.8507. Okay, and then this is an exhaustive list of possibilities. These will add up to 1. So let's just work through the different possibilities that we might want to think about. So 2 aces, that's this, that's 0.00452, and exactly 1 ace, exactly. So that's either this possibility or this possibility. So we add those together, 0.0723 plus 0.0723, so that's 0.115. At least 1 ace. We have to add up these 3, so 1 ace from either of these possibilities, or 2 aces. So that's this plus this, which which gives us 0.149. No ace. No aces is by far the most likely. So that's this possibility here. So the important thing here is to change the number of cards in the deck for each step. And I think a probability tree is by far the easiest way to deal with that, personally.